your Schoology page. I did give you access to what we're going to be using during the Zoom call. So if you want to get on that, it'll be the little Jamboard. It looks like this, okay? And we are going to be starting on slide 9. You guys being 4th period are starting on slide 9 with me. And then at the end of the day, I'll kind of delete the repeats and I'll pick the best one that looks the prettiest and then we'll kind of go there. Yes. Okay. So, okay, let me point out 2 things. Sorry. I did put all your semester 1 stuff here. That means everything from 2020 is right here in semester 1. Okay. And then if you open up your new folder, okay, and you just go to the week, this week or whatever, I did give you kind of your agenda for the week. And if you open up the Monday folder, I'm sorry, this is a lot of clicks. I really need to find a way around this. But if you open this up, it says, welcome back, Happy New Year, and join me on this Jamboard. So this is the link. So if you would like to join me on the Jamboard, you can do that. And there's nothing to watch on the Zoom call screen. So that way, if you're on your little phone or whatever, you can get on your computer, go to the Jamboard, and you'll see everything that's going on, and you can just keep it there for sound. All right? Say that again. Slide 9. Yes. Yep. Okay. So, and I thought that this thing would work, but it didn't, so I wouldn't use it, but your learning target is there. And then here's the video that you're going to be watching today, as well as your exit ticket. Okay. So, over to the Jamboards. Let's talk about kind of what's going on. I'm going to be over on slide 8 for a second, but I'll switch back over to slide 9. We're going to be on slide 9. But, so our learning target for today should be a review. I believe I watched my son learn this in 7th grade, I believe, like little parts of a chemical equation. So like reactants, products, all that. Like this should be a review. If it's not too bad. All right. So remember that before break, we learned how to make words, right? So let me go back over to slide 9. That's where you guys should be with me. So one more time, I'm going to say it one more time. Slide 9, slide 9. All right. So, so looking at this, right? This is a chemical equation, but I don't want you to necessarily think of it like that. Like it is, you guys spent a lot of time and a lot of practice learning these individual words. You learned words, how to say them. You learned how to write these symbols, these chemical symbols like this, okay? So you put a lot of work into learning the individual pieces of this language, right? So just like if you learn a new language, you learn the words, and then you learn how to put those words together in a sentence. And that's the chapter that we're on. We're putting things into a sentence. And then after this, and kind of for the rest of the year, you kind of learn which sentences work, which sentences don't work, and when it's appropriate to do that a sentence and when it's not appropriate to do that sentence, okay? And then you're able to kind of just start speaking it by me only giving you half of the sentence, all right? So you've got a lot of potential here, but it's really important that you're keeping up with putting these words together, all right? So we're making sentences. You're finally speaking chemistry. Sweet. All right. So, so what we've got here is we've got this long, complicated looking thing, but hopefully this isn't as scary, right? I mean, you're probably like, crap, I got to go remember everything from November. Okay. But it shouldn't be super scary. You know, kind of where things are located. So remember, a periodic table is going to help you for the rest of the year. So I'll kind of zoom into this periodic table in a second. And actually, I'm going to slide over to slide this one just for a second. I want to show you one thing. Okay, you don't have to change yours. Well, yeah, you can. I'm on slide 5 if you're going to keep up with me. So what you're seeing on slide 5 real quick, okay, is that I have this little hydrogen highlighted, and then I made this little 7 right here. What those are the diatomic 7. All right. And yes, they sound like superheroes because they kind of are. All right. They have their own unique property, which is that they can't exist by themselves. So you kind of saw me write nitrogen gas up here in the right-hand corner. Okay. If I say verbally, or if I write out nitrogen gas, this is what you're thinking. And if you notice, we're putting a little 2 next to it. Diatomic means that it can only exist with one more of its kind. All right. And I might have mentioned this at the beginning of the year, but I didn't really make you guys memorize them yet or anything like that. So if you do have a periodic table that you've been writing on, this is worth highlighting. Highlight your hydrogen, so that's 1, and then nitrogen, you're going to make a 7 all the way down to iodine. And that's 7 things. You made a 7, and all of those guys, if it is ever mentioned, has to have this little subscript of a 2. Okay, I'm going to go back over to slide 9 with you guys if you're still on that one. Okay, so now we're going to kind of fill in what these different parts are, all right? And we're going to refer to the periodic table in just a second. So first, we've got things on the left-hand side of this arrow, right? So we have these guys written out, and then we have these guys written out, and there's an arrow in between, kind of like an equal sign, all right? And so what we've got, the ingredients that you put together in a chemical reaction, the ingredients, does anybody remember what they're called? Ingredients? Oh, like what are these guys called over here on the left-hand side? Reactants. All right. And then we are putting them together to create products, right? So easy enough. Reactants are your ingredients. Products are what you make. So if you were putting together sugar, flour, I forgot the whole recipe, vanilla and all that stuff, you put those together and you made cookies, sugar cookies, right? So, oh, butter, I forgot butter. Darn, so close. All right, so you got reactants, you have products, right? Then you have this weird little arrow. This arrow tells you what direction this little recipe is going, right? So this chemical equation is going. So this one is showing that it's going to the right. If I wanted to be not conventional, or if I'm just trying to save my room on my paper, I could point it the other direction and say, nope, we're going to go this way. It's just telling you who now is going to be the reactants, who's going to be the products. Okay, so whoever's on the butt of the arrow, that's your reactants. Who's ever on the tippity end, those are your products. Whoever it's pointing to is your products. All right, this is called a yield sign. Okay, now when you go to write reactions for me, I don't mind if you say produces. You don't have to say yields, because I know that's kind of weird. And some of us are getting our driver's license right now, and you guys know that a yield sign means like stop, stop-ish, and proceed slowly and stuff like that. So I don't want to confuse you too much on that. But yield in chemistry means that we're producing, okay? You need to be ready to see that word, though, and know what that means. So that's the arrow right here, okay? Then you see written underneath our reactants and products, you have these little things in red, right? Those are just showing you your states of matter. Okay, and we'll go over that list in a minute. Finally, you have these 2 big numbers right here. And actually, I'm going to make a copy of this little box, and we're going to rewrite it as the one that you guys should know at this point, which is a subscript. Okay, so subscripts are what we were using when we were learning how to write these different chemical compounds. They came from crisscrossing charges, or you had prefixes, right? And those were those little numbers. So here's the thing about subscripts. You can't touch those anymore. You guys have now already made the words or made these equations or these chemical formulas. You cannot touch subscripts anymore unless you are creating it. If you are crisscrossing charges, put the subscript. If you are not doing that, if it is already written for you, do not touch the little numbers. Subscripts are what they are. They name this thing. Coefficients, however, are these 2 big 2s that are right here. Coefficients are what you guys are going to deal with on Wednesday, okay? I put together a little video thing for you guys on Wednesday. And so coefficients, you're going to be balancing these equations. So tomorrow we're going to learn about law of conservation of mass, which means that whatever you start with, you end with, right? So if I only have ingredients to make 10 cookies, I'm not going to magically create 25, right? You got to start with and end with the same things, okay? And so we're going to be adding in these big numbers, these coefficients, to kind of balance it out. And these coefficients apply to everybody behind it. So this means now that I have 2 sodiums and 2 chlorines, just like the subscripts went for whatever was in front of it, okay? I'm sure I'm talking way too fast and you guys are like, what's chemistry? Just hang in there. All right, so let's look now down here. Okay, so we have we'll go to equation to words after. So let's talk about these funny states of matter symbols. So AQ, that is aqueous. Okay, aqueous means, so as, for example, I have this, NaCl. So we know that's ionic because Na is a metal, right? Metals are over here. Chlorine over here, so sodium chloride. Sodium chloride is table salt. You probably have some in your kitchen, right? So if I took that table salt, I put it into some water, mixed it up, I just made NaCl aqueous, which is a solution. That is everything that we deal with in chemistry. If you go into my storage closet when you're finally on campus, you'll see shelves of all these bottles of liquidy looking things. Those are all solutions because they're all some sort of a solid mixed into water, dissolved in there. It's a solution, okay? So aqueous is going to be the most common thing that you're going to be writing. AQ. Don't write L. That's wrong. All right, S. S is going to be for solids. So we can see in this example that I have right here, a solid ended up with this, right? So we had two aqueous solutions that we mixed together, and then we produced a solid. That is a sign of a chemical change. That's a precipitate. So you guys being pre-P, I'll be holding you guys a little accountable for the word precipitate. Not yet, but wanted to put that out there. Okay, so this Jamboard is worth coming back to look at the end of the day. Okay, so that you guys remember these words. All right, L. L is liquid. That makes sense. However, this is complicated. And you're probably going to overcomplicate it later. Liquid and aqueous are not the same thing ever. Liquid means that its state of matter as a pure substance is a liquid thing. That's why I had to add in this molten metal. If you've already watched the video for today, you saw that his example was iron. It was iron with an L, right? That meant that it was iron melted, just like they do in the movies when they're making swords and things like that. Okay, molten metal means that it's in a liquid state, which just means that that sea of electrons is a little more free. Okay. All right. Otherwise, you guys in Chemistry 101 will be using it for water and pretty much only water. Okay. So if you're going to remember, if you're going to try to simplify it in your brains, liquid goes for water and that's it. This will rarely happen with y'all. Okay. This is more like AP level. We start putting in molten this and molten that and throwing them off and stuff. So liquid, keep it to water, put aqueous on everything else. Okay. Unless we tell you it's gaseous or solid or something. All right. Finally, G is going to be gas. We'll see that in the next example. All right. So what this is going to help us do, okay, is if we were to put this equation into words that we're seeing right here, we would say a solution of sodium chloride, if I can type, reacts with aqueous. I want to show you guys how this can be written. All right, let me stop there for a second. Let me stretch this out. There we go. With aqueous, and then looking here, okay, just a reminder from last year, 2020, okay, lead is down here. Lead is right here. That means it's a transition metal. Those were the complicated ones that you guys hated the most where you had Roman numerals. So here's your little hint to get by, okay? Remember, you can always do a reverse crisscross. So the fact that there's a 2 right here, I can reverse crisscross that, and that means that this guy's charge was a 2. You can kind of rely on that, okay? There's a few exceptions to that, but for now, I would just rely on it, all right? And so if we send that up there, that means that this was lead 2. Lead 2, and then this was a polyatomic ion. That's in your resource sheet as well, okay? So nitrate. Okay, ooh, I don't know what I wrote. Nitrates. And then I could say yields, or we could go ahead and say produces. And then we're going to start talking about our products. So we have a solution of sodium nitrate and solid lead 2 chloride. Okay, so once again, I did that little reverse crisscross. That's how I was able to come up with that. The rest of these were all ionic substances. So don't forget little basics like that, okay? But I wanted to write it this way so that you could see different ways that I use the words. You can come back to look at this later. Usually when it says solution, I should have said probably aqueous here and solution up here, but it's okay. All right, so just use those words interchangeably. Start to kind of become familiar with that. All right, the thing I'm going to end with is this one. It'll be really fast. What I'm going to do is we are going to take these words. The only thing that I'm not showing you right now is using those little coefficients. We could say 2 parts sodium chloride, 1 part this, or 2 moles of this. There's a word that from Molde. Okay. So you'll start seeing that. Don't worry about it too much yet. I think he shows you in the video, he draws it out, and you'll get there on Wednesday. Okay. All right. So on slide 10, we're going to look at this one if you're following along with the slides. So once again, we shifted to slide 10. It says gaseous dihydride reacts with gaseous dioxide. So before I just dive into this, I made this one easy for you because I went ahead and gave you guys the prefix. You all being pre-AP are not going to get this all the time. I would say gaseous hydrogen. I would just say gaseous hydrogen. And you guys should now be recognizing, oh, hydrogen and then any of these 7 naturally go to di, meaning they have 2. Okay, that's what I meant by the little diatomic molecules, all right? Okay, or diatomic 7. All right, so let's finish this up so that you guys can go because you guys look bored. All right, so we got gaseous dihydride. So, oh, I was holding the pen backwards. I was like, why isn't it writing? Okay, so we have gaseous dihydride. So we're just going to put H2 with a G. Okay, so gaseous mixes with gaseous dioxide. So I have dioxygen. Okay, gaseous. And again, that's another diatomic 7, oxygen is. So I could say oxygen gas. With the addition of heat. Whoa, what is that? I didn't talk about that on the last one. This is what I mean. You're going to be putting a little delta symbol. Okay, which is just a little triangle. You just add it on top of the yield sign. That means that I got to heat it up. Okay. With the addition of heat to produce liquid dihydrogen monoxide. Good old prefixes to start us off. All right, so we got dihydrogen monoxide. That's water. Okay, so we got H2O, and we're going to throw the liquid because, first of all, it's water, and plus, I also told you, right? Okay, so the last thing, and this is what you're going to cover on Wednesday, so don't worry about the balancing yet, but what you should start looking at is I have 2 oxygens here. I only have 1 oxygen here. So we're going to have to be fixing that when we get to it on Wednesday. So what it's going to end up looking like is we're going to throw a coefficient here and a coefficient here to balance it out. So we'll go over that a lot slower Wednesday, so don't worry about that yet, but please recognize we've got coefficients. Sorry, we have coefficients. Right? So these big 2s are coefficients. We have our reactants, we have our product, we have our states of matter, and we have a yield sign. Those are your basic vocab words you got to get today. I'll let you guys go. I'll see you guys tomorrow. Okay? Stay on if you need to chat. Bye. Happy New Year.